Stonehenge a few years ago. Complete, actually, if you look carefully, there is even, let me just see, there we go. There is even a raven at the top of that. It's a perfect image. I took this on Valentine's Day because that's the kind of romantic guy I am. I took my wife down to that and, took my kids, and they're kind of like going, yeah, shit, they really are that big and all the rest of it. It turns out this is one of the major technological achievements of Brexit Britain. It's a classic legacy system. We are not entirely sure who built it. We don't know why they built it. It's difficult to maintain. We don't know what it was for, and twice a year it works. And everybody's afraid to touch it. So, let's talk about refactoring. And I'm saying it's not just clickbait, because for a lot of people, refactoring has kind of forked into two different meanings. One meaning is, oh yeah, I've got a little kind of shortcut key that allows me to rename things. And it's just a quick click away and that's it, I'm done. And for other people, it's, oh, okay, that's months of re-engineering, but they call it refactoring. And, we don't do refactoring because, we can't have a refactoring sprint. And the other is that it's large in scale. I want to try and reclaim the word, but I want to put forward the idea, and it's not a new idea, that refactoring is a design practice. If you're not doing refactoring, then what exactly is it that you're doing? Okay? So, presented with such a thing, there is a certain intrinsic beauty to this thing. And these were the developers of 4,000 years ago. They used what they could. And funnily enough, they actually reused stuff. That's a different talk. But it's quite complex. And this is the observation from Neil Ford. Developers are drawn to complexity like moths to a flame, often with the same outcome. People can't resist complexity. Complexity, because, as I said in yesterday's keynote, developers are a perfect storm of two very distinct qualities. Well, many distinct qualities, but there's two that I think are quite important. One is they are problem solvers. Two, they are creative. Not all people who are creative are problem solvers, and not all people who are problem solvers are necessarily creative. But you put these two together, and somebody will always look at something and go, yeah, I can solve that, but I can make it more interesting. I can use, let me think, what day is it today? Thursday. There must be a new JavaScript framework out there. Okay, so I can use that. Or I can be the person responsible for creating the framework. Because obviously the world needs another framework. And actually, maybe I shouldn't do it in JavaScript. Maybe I should do it in TypeScript. Or maybe I should do it in Kevlin script, which has not yet been invented, but I feel that would be appropriate for the task in hand. I will create a DSL of such perfection that everyone will bow before it and go, that's really cool. And then I will abandon the project halfway through and leave more legacy for more people. Okay? And maybe it needs to do this, and maybe it needs to do that. Yeah, we can do that. And maybe I need extra hooks for the... Yes, we can always find something more complex. Now, people often associate this with technical debt. Now, I'm doing a half-day workshop this afternoon. I'm going to talk a bit more about technical debt this afternoon. Technical debt's not really the problem. When most people say technical debt, what they actually mean to say is unmanaged technical debt. Debt is not a problem unless it's a problem. Sometimes we take on debt for structured purposes. We take on debt to achieve something we could not otherwise do. And that's the whole point of the metaphor. It's a real-world metaphor. Yeah? If my wife and I had not taken out a mortgage, we would not own a house. Okay? That was a structured debt, understood consequences. No, it was not a problem. That's the whole point of the debt metaphor. You can have managed debt and you can have unmanaged debt. So when most people say we have technical debt, so what? Tell me what you've really got. We have unmanaged technical debt. Now we've got to the problem. If you say, we have lots of technical debt and it's highly managed, highly structured, and we have a repayment model for everything, go you. Well done. That's not a problem. The possession of technical debt is not the problem. It's what you do with it. What most people actually need is a different metaphor. I've started talking about technical neglect. That's the problem people are experiencing. It's not debt, it's neglect. The question is, people come and say, oh, we have debt as if it just appeared overnight. How did you get it? Through neglect. That's the process of accumulating it. You're focusing on the effect. The cause is this. You're just not caring. No, that's not, you're not caring because you're a bad person or anything like that. In software development, actually, pretty much, people are pretty nice. Compare it to some other professions, people are pretty nice in software. But we have so much to do. There is so much complexity inherent in software development. There are so many things to know. There are so many things going on. You cannot know everything and pay attention to everything all of the time. So neglect is going to happen. Acknowledge that. The question is, what do we do about it? But sometimes we make compromises we are uncomfortable with. Sometimes we learn things and we go, oh, there's a better way of doing this. So the commit strip cartoon, I love commit strip cartoons, great stuff. Got a project manager talking to a developer. So will refactoring the code improve the loading time? Not really. So will it improve security then? No. So it's for browser compatibility? Absolutely not. Here we are trying to establish what is it that we mean by refactoring. Because it clearly takes work. But it's not obvious what it means. So tell me, why is it always the same old story with you guys, wanting to refactor everything? I need to know. Because as devs, if we know we've left messy code, we can't stop thinking about it. When we wake up in the morning, at lunchtime, in the evening, when we go home, and when we're trying to go to sleep, it haunts us, you know, it haunts us. Sometimes you just know that piece of code could be better. You did a compromise, perhaps you did the best thing that you knew. Guess what? On the way home, you discovered there's a better way. You thought about it. I always find that notion of taking yourself to a different context, just taking a break. It's just like, there's a better way of doing this. Maybe you're actually on holiday, most unfortunate, and that's now going to dominate your mind for the rest. There's a much better way of doing it. Oh, damn. Don't log back in. Don't do that. But the point there is you recognize these things after the fact. Software development is a process of knowledge acquisition. You are learning constantly. You're not going to, the first time you do something, you're not going to know the best way to do it. And that could be just a tiny piece of logic. It could be something massive and architectural. Why should you know everything? You realize after the fact. But there's another thing, another reason we want to care about this stuff, and it relates to the term neglect. There's this lovely metaphor by Brancusi. Architecture is inhabited sculpture. When we use the metaphor of software architecture, we often forget that, we often think software architecture, oh, that's about structure. Yes, it is about structure. It's about purpose. Yes, it is also about purpose. But we always forget that in the real world, one of the most important parts of the metaphor is architecture is for people to live in. The same in code, the same in a code base. It means we can ask questions like, is this code base habitable? Do you want to live there? Do you want to work there? And you go like, oh yeah, I love that part of the code base. It's beautiful, it's so well lit. There's these beautiful tests that shine upon it, and the code is all shiny and clean. And I feel comfortable working within it. I feel safe working with it because I can make a change and I know immediately whether I've done the right thing. And it's always I always understand what it is that's going on in that code. I love that code. What about that piece of legacy code over there? Oh no, I hate that. Its classes are large and forbidding, and they are cold and dark. And we've sent developers into those classes before, and we've never seen them again. We're on a recruitment drive. So the point there is you want something to be inhabited. You want it to be a good, comfortable place to live. You don't do that passively. It takes effort. It's a continuous effort. Now, there's this lovely observation. This has been variously attributed on the internet to pretty much everybody. I think Michelangelo normally gets the credit for this one, but I'm sure if you look hard enough, because it's the internet, you'll find Albert Einstein and Abraham Lincoln as well. But it is actually George Pentecost. It is much more recent. There is a beautiful angel in that block of marble, and I am going to find it. All I have to do is to knock off the outside pieces of marble and be very careful not to cut into the angel with my chisel. But we in software development have a superpower. We have time travel. This is way cooler than any other profession. Okay? Because we can look at something, we can make a mistake, and we can hit undo. We can revert to an older version. If you are in a company where you still have business cards, I know that's itself kind of interesting, but if you find yourself in need of a business card, time traveler, cyber time traveler sounds even cooler. Christmas is coming. Members of your family may meet you and ask you, what exactly is it that you do? And could you fix my computer? I'm offering you a new path. I'm offering you the ability to say, I'm a traveler of time and space. I am not chained to such earthly things as hardware. No, I will not fix your computer. I wander the byways of time and code. That's what I do for a living. We can chip the marble in the wrong place and still get it right, because we get to go, nope, run time back. We have the time stone. We get to reverse it. And that is the whole point. Refactoring is a process of discovery and recognition. It's a process, if you like, as opposed to proactive design, it's reactive design. We've built this, now we understand it. Proactive design is, I think it should look like this. Reactive design is, now we know it looks like this and we know more, this is how we respond. Software is supposed to be soft. It is the perfect medium for this. You actually notice that in this book, this is the original refactoring book published in 1999, Martin Fowler, Improving the Design of Existing Code is the subtitle. The clue is there. He's kind of saying this is an active process. You don't have to have that feeling of inevitability. Oh, it's a legacy code base. It's always going to be like that. No, he's saying you can actually reverse that. You get to reverse the arrow of time. And there are a number of other contributors, Kent Beck, John Brandt, Bill Opdyke, Don Roberts. I'll come back to Bill Opdyke in a moment. So let's find a definition of refactoring. Refactoring is not just arbitrary change. It's not an optimization. A definition is provided. Change made to the internal structure of software to make it easy to understand and cheaper to modify without changing its observable behavior. I'll come back to what we mean by observable behavior in a moment. What is interesting, this definition is very clear. We're not trying to achieve anything except an improvement in the ambience and habitability of the code. But more importantly, from an economic perspective, is I could add that feature, or I could change the code and then add that feature. And this is a really important idea because it's very easy to fall into the trap that we often do with code bases of addition. We tend to think additively. We add to code bases. That's actually where most of our problems come from. It's adding things. It's also, by the way, where most of our estimation comes from. We imagine, what does it take to add something? But it turns out that to add something, you have to always modify something. So maybe we should modify it first and say, how do I modify it in such a way that adding the new feature is trivial? In fact, this is a conversation I had with a friend of mine a while back. He actually did a presentation, which is unfortunately not publicly available, on refactoring-driven development. And that's something I'd really like to talk a lot more about, but I'm not going to talk about it today. But refactoring-driven development, when I was talking to Rolly, I found that he had a very similar approach to me as to how to think about code. He said, oh yeah, I do about 30 commits, 29 of which are refactorings, one of which is the actual change. In other words, I move the code so it does exactly what it did before, and then the last moment is the addition of the feature. In other words, adding the feature is trivial. That's a different way to the way that most people develop. However, there is a process here. And there's a lot of ideas that come out of this. It's not just a click. Interestingly enough, without changing is also what we see in the second edition of the book, which came out a couple of years ago. And in the second edition of the book, identical except for the fact that it has 20 years more experience, and it uses JavaScript rather than Java. But let's go back. Let's talk about time. Where does this refactoring stuff come from? It's not Martin Fowler's. It's not it. I first heard about refactoring in the context of extreme programming. Extreme programming is kind of Kent Beck's baby, kind of the agile approach that triggered people's interest in agile approaches, the thing that gave us test-driven development, the thing that gave us pair programming, and popularized these things, the things that popularized continuous integration. Radical, provocative, massively influential from about the mid-1990s onwards. That's where I first heard about refactoring. But even that's late. This is Bill Opdyke's PhD, submitted in 1992. He started work on this in the late 80s. If you look, his PhD advisor is Ralph Johnson, who later got fame via being one of the Gang of Four, Gamma, Helm, Johnson, Vlasides design patterns. And his work was on refactoring C++. Interestingly enough, one of the languages that has received the least love in terms of refactoring was actually the first one. A lot of people tend to associate refactoring with, oh, that grew up in Java. And it did grow up in Java. That's where it became commercial. That's where it became widespread. That's where it got adopted by IDEs. That's where the idea of refactoring became normal. All other languages then followed, up to a certain point. But here we see his observation. The refactorings are defined to be behavior preserving. So let's kind of figure this one out. What do we mean by this? So let's have a look at, possibly the most overspecified abstract data type in the history of computer science, the stack. Because who doesn't need one of those? And I will offer 4 simple operations on it. The depth, because a stack is a vertical concept, so you can use depth or height, you can't use length, it doesn't make sense. The top, and push and pop as actions. And I'll render this one in JavaScript, because why not? It's Thursday. And I will use a kind of a pure object model, as opposed to JavaScript's object model. And I will use this in terms of closure. I will keep my state private. I will capture the closure over a block, which is effectively the implementation in terms of an array. And then I will use lambdas that bind to that, and I will return you a pure object that has effectively a Cartesian product interface of depth, top, push, pop. These are the lambdas. And yeah, it's kind of cute. It's all one-liners, intentionally so you can read it. And that's one implementation. And here is another implementation. What I've done here is I've just refactored it to reverse. In other words, in this particular case, the previous case, the top of the stack is the last element of the array, whereas in this case, the top of the stack is the 0th, the initial element. I've just done, so a refactoring where I've reversed the representation. This can actually have a performance impact. Not that it's going to be hugely measurable in something like JavaScript, but in some languages this may be significant as to where you are putting things. Importantly, nobody outside this piece of code is affected. It is a refactoring. I have changed something about the code, not necessarily to make it easier to understand in this case, but I have changed the representation and I've moved between these. It suggests I probably want to have tests. That's a good idea anyway. But there is the idea that I have not changed anything about the public API, and honestly, I don't care about the performance. So let's understand the changes that you might make. This is approximately a right-hand rule. On this, I will overlay 3 axes. The functional qualities of a piece of code, the operational qualities of a piece of code, and the developmental qualities of a piece of code. Functional qualities are the semantics. That's the values, the events, and things like that. This is the stuff that you most obviously think of when you think of behavior. In fact, for some people, this is what they mean when they say behavior. And that's actually what the Martin Fowler quote and the Bill Opdyke quote, they use behavior to refer to functional behavior. But there's another kind of behavior, operational behavior. How does it run? How much memory does it use? What about its performance? Operational is about use of time and space. What about developmental? developmental qualities of a piece of code are those that we experience at development time. The other two are experienced at runtime. Developmental qualities are things like, well, the habitability, the maintainability of the code. As a developer, what does it feel like to be in that code base? Okay, that's another aspect. So if we treat these as a roughly orthogonal, and given that my fingers are not perfectly at right angles, that's okay. These are not perfectly independent, but it's a rough model. We can now understand that when you're adding a feature, what you're doing is you are increasing the semantics. This now has more functional behavior than the previous commit. Okay, it now has more of that. We added a feature. Okay, so what happened to the performance? Well, typically it probably stays the same, but maybe it gets a bit better or maybe it gets a bit worse. But the idea is it's not our focus. It's not what we are trying to achieve. What about the developmental quality? I mean, obviously it'd be nice if it didn't get any worse, but that's not our focus. Maybe it gets a bit better for some other reason. Maybe it does get worse. The goal of feature addition is to add semantics. Interestingly enough, this is also the goal of bug fixing. Normally with bug fixing, however, it's not a case of you have this behavior, feature addition, you have this much semantics, now we give you this much semantics. With bug fixing is we promised you this much semantics and you have this much semantics. You have a shortfall, you have a deficit. What you're doing is restoring the promise. Oh, okay, yeah, here we go. The other two axes are wild, they are open, they are not controlled. But let's try and control them for something. Optimization. Optimization is a semantics preserving operation. Optimization may be, our goal is to improve some aspect of performance. Maybe it's speed, maybe it's memory usage. Okay? Maybe it's throughput. Whatever it is, we want to improve it. That's our goal with optimization. We also have another goal, which is don't break it. And when we say don't break it, we mean the semantics. That's what we mean. There is no point in somebody coming forward and saying, hey, it now runs 10 times faster. Yeah, but it's buggy as hell. But those are really fast bugs. That's not a win. What happens to the developmental quality? It's easy to assume that the developmental quality must necessarily go down. In other words, it becomes more complex. Okay, a piece of code that has caching is more complex than a piece of code that doesn't. That's not to say that it wasn't necessary, it's just more complex. Developmentally, it is harder to work with. On the other hand, there is the observation that there is no code faster than no code. Sometimes the best optimizations are the removal of things. So guess what? It goes faster, and it's easier to maintain and work with. But the idea is that that is the open category. We keep one fixed, we move along another, whatever happens to the third, happens to the third. This now sets us up for refactoring, which is also a semantics preserving operation. Here, however, the goal is to keep not only the functionality fixed, we leave the operational axis, who knows what happens? Developmental, we're making this better in some way to afford the next change or other changes. Now, this simple way of understanding how to navigate this XYZ structure is really helpful because it can also help you with your commits. What is it that I am doing? What is it I'm about to check in? You might check, don't be like a guy that I worked with years ago. His name was John Smith, which is a hugely anonymous name in English. And his check-in comments were also hugely anonymous and vague. Every check-in was added some features, fixed some bugs, tidied up some code. Copy, paste to the next check-in. Come on, Make your check-ins move along one axis intentionally at a time. Okay, then you can roll back. Oh, this check-in was about improving performance. I did not change any functionality. I did not intentionally choose to improve the code. Okay, this was a pure refactoring. I fixed no bugs. I changed no performance intentionally, but the semantics is identical. So in other words, it gives you a much easier language to work with. You're creating a space through which you're navigating. Now, if we're navigating, that means we're doing things. Let's talk about the verb, refactor. What is it we are doing? To restructure software by applying a series of refactorings without changing the observable semantic behavior of the software. Now, what is interesting here is when do we do this? There's a couple of things here that I want you to notice that are quite interesting. The one thing I'm going to pick on, a series of refactorings. There's lots of them. The idea is that when you are refactoring, you are undertaking a journey. You're not just doing one thing, you are doing another and then another. The idea has always been that you are supposed to refactor to the point where now the next change that you make, now you make it, it's so much easier. But sometimes that's not just a renaming, an extract method, or an extract interface. It's a path. It's a series of changes, each one of which is taken deliberately with the goal of being stable and not breaking things. And when do we do this? Well, don't save it up for a big sprint in the future. There's this lovely observation from the author Annie Dillard. How we spend our days is, of course, how we spend our lives. If you are not refactoring today, then why would you be refactoring in the future? Refactoring is something you do always. It's a continuous practice. It is part of design, it is part of coding. It's not something you do separately, any more than, somebody might say, well, I wrote my code this morning. This afternoon, I'm going to put the semicolons in. You don't, why? Because I've separated semicolon adding as a separate activity. Well, no, you don't do that. This is part of the flow. It's not a separate activity that you need to schedule. I've heard of companies that have refactoring I've heard of companies that still have timesheet codes. Often companies with billable hours tend to have this, timesheet codes. But timesheet codes for refactoring, no, it's called software development. That's what we call it. Yeah. Now, importantly, many people associate refactoring with automation, and indeed, that was the goal of what Bill Updike was looking at. The focus of the thesis is on automating the refactorings in a way that preserves the behavior of a program. So let's have a look at a really kind of simple example. I'm going to take it from the book that I edited a few years back. It's kind of an open source book, so you can actually find this stuff online. Somebody put it on GitBooks. And I always use Dan Terhorst-North's piece, Code in the Language of the Domain, because there's a lot here that I think is really interesting in such a small example. He presents this piece of code. If portfolio IDs by trader ID get trader.getID, contains key portfolio ID, .getID. What is this? Does it need renaming? Well, not really, because all of those names are really good. The only abbreviation there is ID, and that's a real-world abbreviation. That's not a programmer abbreviation. And yet it's not clear what the intent would be. Now, some people say, oh, you should add a comment. Well, what would the comment say? What's going on here? The complexity here, or rather, there is a renaming. What we are trying to rename is what the whole thing is called. We're not renaming a single element, we're renaming the whole thing. If trader can view portfolio, so this is for an investment bank. There are rules to prevent insider trading. And the idea here is that you have permissions. There are certain portfolios you are not allowed to access. There are permissions on this. So therefore, if you're a trader and there is a portfolio, this answers the question, can you view it? Oh, okay, that's cool. That's nice and easy. But what we just did there is perhaps one of the most common refactorings. Most refactoring is about adding intention to the code. We haven't really changed the structure of the code in a deep way. We've just moved things around. We have renamed things that had no name. We have extracted method, one of the most common refactorings. So I made this comment last year. One of the great things about languages with modern IDE support is that thanks to refactoring tools, legacy code is a thing of the past. Unlike with older languages, developers never have to experience long methods, rambling classes, poor identifier names, complex logic, etc. For those of you who started developing software this century, I envy you. You will never have to experience legacy code. You will never have to experience classes that are thousands of lines long. You will never have to experience methods that have their own gravitational field. They are so large. You will never have to experience bad class hierarchies. You will never have to experience poorly thought out logic. You are so lucky. since we have had automated refactoring, we solved the problems that have been plaguing people for decades. You know, when I tweeted this, some people, I mean, okay, I get that I didn't put a smiley here. And I get that not everybody knows that I actually have a sense of humor, and a very British sense of humor at that. But some people kind of jumped in and so on. All they had to do was wait a moment for the next tweet and then the next tweet. Because it turns out that we solved the problem, the thing that everybody complains about, we solved it. It's a solved problem. It's fantastic. We've solved the problem of how to reduce bugs. We've solved the problem of on-time delivery. We've solved all of the technical debt problems. We've solved all of the code problems that people complain about. No, that's not true. I don't want to overstate the claims. We have solved 95% of the problems that people complain about. There's 5% there that's proper and interestingly hard. But most of the problems people experience on a day-to-day have been solved from a technical perspective. And what this reveals to us is the problem was never about the tooling. It was about us. It's about our knowledge and about our sense of permission and ability to do so. Technology will extend your reach, but if you're not reaching, it doesn't matter what technology you've got. You have to know how to do this, but also you have to feel enabled to do this. The problem was never with the tools. I've done refactorings in projects and not had any refactoring tools. In fact, there are most of the refactorings I use do not have a name and are not automated. And you know what? I can still do them. But that's because I really think that that's an important idea. And perhaps because I had a really interesting experience when I started working in software. One of the first systems I ever worked on was based in Fortran. And let's put it this way. My boss did not believe in such nonsense as code indentation. Let me tell you, it was fascinating and you learned a lot. The hard way. And that has shaped my experience ever since. How do I not have that situation again? But that's a very personal experience. It turns out it didn't need tools. It's a mindset shift. But in this thread last year, I asked, seriously though, some general refactoring questions. One, what family of refactorings do you find you use most, whether automated or not? And two, well, we'll get to two in a minute. So the answers to this will probably not surprise you. And obviously this is a totally unscientific poll, you know, but it's kind of like, it was just generally, have I missed anything? That's what I was trying to do. Guess what? Extract method, hugely popular. Rename. Now, what I find interesting, notice it's not extract. Rename is actually a family of refactorings. There's rename variable. There's rename method, there's rename class, there's rename. All of these have slightly different consequences, but we understand them under the same name, and our tools tend to bucket them under the same name. But I find extract method, it's interesting. I'll tell you why extract method is interesting in a moment. But rename. Yeah, that one, rename and extract method are probably in your head, probably the top. Of course, there are points of resistance with rename. It's not always easy. You can't refactor everything easily because there are boundaries of resistance. There are architectural boundaries. We have to respect those. When I said that 95% of the problems have been solved, yeah, this is in the 5%. My favorite story about this one is I'm going to pick on clonable. Now, if you're in the Java space, you're looking at that going, yep, that's an interface. It's been in Java since 1.0. Actually, it's been in Java since before 1.0, or 1.0.2 if you want to be pedantic. And so then .NET comes along. And Microsoft say, me too, or me, clonable. Let's put I in front of everything. It's a terrible habit, but yeah, that's a separate discussion. It jumps the gene pool from Sun to Microsoft. There is one small issue, however. In as much as there is a correct way to spell anything in English, clonable is spelt without that first E. Now, a lot of you are thinking like, oh, Jesus, English is such a mess. It doesn't have a regular spelling system. And that, my friends, is where you are wrong. English has about 9 or 10 regular spelling systems, all at the same time. That's the challenge. It's not that it doesn't have one, it's the fact that it has lots of them. And in this particular case, this is how we spell clonable. The funny thing is, this was actually known back before the first public release. And recently I asked Twitter again for its wisdom. That was just before Elon kind of fucked everything up. And I finally found the answer, because I knew I'd read this somewhere, but it was over 25 years ago. I couldn't remember where I read it. And it's immortalized. Clonable is misspelled. There is a bug report here. This is January 1996. There is a bug report here. Clonable is misspelled with only one E. It's spelled with only one E. Ask any geneticist, including my wife. Always good to bring in authority. English specialists such as Henry McGilton. There's an interesting thing here, which I'll come to in a moment. English is missing a G, and McGilton's got an extra U. McGilton does not have a U. It's embarrassing. Let's fix it before we ship. We can't fix it after, and right now, very little code relies on this typo. There is an interesting thing. It's a law. It's known as Muffrey's law. Muffrey's law. If you write anything correcting or criticizing the quality of someone else's editing, proofing, spelling, grammar, etc., there will be some kind of editorial error in what you have written. Yeah? Hey, this is spelt wrong, so they spelled two things wrong. Muffrey's law is a specific application of Murphy's law, that anything that can go wrong will go wrong. Now, if we go to Wiktionary, there we go, we see clonable. But look what we did. Look what we as a collective community, as software developers did. We have changed the spelling of a word. Oh, we don't just mess with time, we mess with spelling. I also offer you a HTTP referrer and a bunch of other spelling mistakes. It's really hard once it's out in the wild. Okay? Public APIs, like diamonds, are forever. But this also gives us an interesting thought about how we should think about our development. And again, this is not news. Martin pointed out, don't publish interfaces prematurely. In other words, before you publish them and make them available for other people to have dependencies on, don't be in a hurry to publish things. You don't have to publish everything. Not everything needs to be in an API. Not everything needs to be available. Just try it out first. Take a kind of perpetual beta model, kind of like understand how to deprecate your interfaces. Come up with an interface retirement policy. Figure out that it's a process of growth and maturity, not big bang release. Be sure of the things that you're releasing. And the only way you can be sure is to try them out, keep them for a while. And importantly, change the way that you develop. Modify your code ownership policies to smooth refactoring. In other words, to keep your software soft, you must invest effort. Now, there's an interesting thing here, because this is really useful advice, but it goes against advice that a lot of people seem to try and apply, which I think is absolutely terrible advice. There's a thing called the open-close principle, which is misunderstood because it's actually, the way it's been promoted is incorrect. I'll leave that to one side. But the open-close principle says that you should make your classes and other things open to extension and closed for modification. That's a terrible, terrible idea. As a principle for class design, this is how we create complexity and how we create debt that is unmanaged. Make code as open to modification as possible. It's the exact opposite. Your goal is, when I have made some code, I should be able to come back to that code and change it. Why can't I? Oh, because I'm following some random principle. Give me a real reason. Let's talk engineering. Why are you making the code hard to change? It's supposed to be soft. I recognize there is a small portion of code that may not be open to this, but not everything is an API. We want the exact opposite. And don't make everything extensible. That's crap. That's a 1990s idea. Hey, yeah, we can extend anything by inheriting from everything and plugging everything into everything else. I've seen that code. There is nothing good about it. Yagni, you ain't going to need it. Resist the temptation to make it extensible, because if you make it easy to change, when you come back to it later, you'll go, oh, this needs to be extensible, and now you know it needs to be extensible, and you can change it. If you tie your own hands behind your back and prevent yourself from learning, you end up with the open-close principle. Open-close principle is a dysfunctionality. It's not a benefit. It's a bad practice. So, yeah, refactoring is important because it's about learning. But let's also learn what it is that we don't do. What refactorings do you feel are most overlooked or underutilized by you or others. This is why extract is interesting, because people are quite happy to extract method. But my goodness, the psychological barriers to extract class are massive. Well, if I extract class, then I need to name the class, and we know that naming is one of the hardest things you're ever going to do. And that also means it's probably going to be in a different file, and that means I'm going to have to commit a different file, just keep it in the same place. Extract method. We'll just pile it all up in this class. What's it called? Oh, it's something manager. Yeah. One of the best classes I ever came across that needed such love was called Workflow Process Manager. That's 3 words, just all they met randomly in a bar. What do you mean? I have no idea. I'm just workflow. Oh, okay, what do you do? I'm process. Oh, I'm manager. Well, what do these words mean? We have no idea. Let's hang out. We have something in common. It was a masterpiece. It was 15,000 lines of complexity that was saying, please refactor me, and everybody's going, oh, no way. Inline, the opposite of extract. Take something and put it in line. This is really important because it allows you to suddenly realize, I have made a refactoring. I pulled something out, but actually this should go back in, because then I can refactor the main body it comes from. Replace. Replace one thing with another. Replace control flow with a pipeline. So if you're working in Java, Java Streams is a good example. Replace a big switch statement with polymorphism or a table lookup. We don't see a lot of this. Delete. Yeah, my favorite. So I coined a phrase a number of years ago and eventually tweeted about it in the next decade. We keep talking about incremental development. We don't talk enough about decremental development. Okay? Decremental development, getting rid of stuff. You know, this is what we do. If you like the software as gardening metaphor, this is very powerful. You cut back in order that your garden may grow better next year. So let's look at a little example and see how that plays out. Yeah, Roman numerals. So here is the enterprise way of programming Roman numerals in Python. Let me show you it in its full glory. If you are being paid by the line of code, ignore everything I'm about to say. What I find interesting about this example is that it actually manifests what we see as a really common trait in enterprise code, the addition of logic. We add logic. It goes back to that comment I said, oh, we're going to add stuff. We're going to add stuff. We end up with, this is very procedural. It's very imperative. We've got conditions. We've got 2 variables, and both of them are changing at every single opportunity. And this is obviously a bad practice, so imagine my surprise, because I'm quite interested in the history of programming, and I collect old programming books. Now, if those of you are old enough, you'll remember, oh yeah, Pascal was the teaching language. And everybody walked around saying Pascal is a good language. It represents good practice and good design. You know what? I used to fall for that. Why? Because everybody said it was true, so therefore you fall for it. I've worked out that Pascal is a terrible language. It's really crap. And then whenever I've said that, I've always had somebody come up to me and say, oh, yeah, but I really like Pascal. Oh, what do you use? Delphi. And I said, that's not Pascal. That's extended Pascal. The language is so bad that you can't use it unless somebody extends it. So I won't have a fight with the Delphi people unless they want to claim that theirs is the true Pascal. It isn't. Here is Pascal, and here in the body of this book is, that logic on the right-hand page. That's exactly the same logic. This is good practice. That's because Pascal doesn't have good data structuring. It lacks the ability to create lookup tables easily, which is one of the most fundamental ideas. Why is it the most fundamental idea? Right, so let's go about how most people would try and refactor this. They would look at this and they would say, you know what, there's a recurring theme. So let's try and change this. And obviously, at refactoring, we change things in small steps because we don't want to break things. So I'm going to have some tests. You can actually, there's tests on a slide just so that you know that you don't need a big testing framework. There's no testing framework here, but this is enough to give you assurance that you are making some sense here. But what most people will do is they will recognize that there is a little grouping here and here and here that looks almost the same. In other words, the grouping looks like this. It's while, if, while, if, while, if, and then a final while. And when we look at the numbers, we realize 1 is 10 something, so 10, 100, 1,000. 1 is 9 something, 9, 90, 900. 5 something, 4 something. And then we have ones at the end. So people will instinctively reach for, guess what? Extract method. That's the wrong way of doing it. Let me offer you a different approach. If you want to do extract method first, hold yourself. I'm not saying it's wrong, but a lot of the time it's not your best path. Here, it turns out that if is a limited form of while. Think about it for a moment. While can repeat 0, 1, or many times. Under certain conditions, we can consider if as executing 0 or 1 times. In this particular example, this works. We have tests. I can actually replace all of the ifs with whiles, which now means my repeating unit of structure is this. Far simpler. And we realize then, oh, that's all the control flow that I need. This is actually a data structuring problem. It's not a control flow problem at all. It's a completely different paradigm. Most people's use of extract method merely tidies things away, but keeps the mess, but just in the cupboard. Here, what we're doing is you recognize the paradigm. This is what we mean when we say, oh, you're redesigning. This is not a new observation. Mythical Man Month, Fred Brooks observed that representation is the essence of programming. Sometimes the strategic breakthrough will be a new algorithm. Much more often, strategic breakthrough will come from redoing the representation of the data or tables. This is where the heart of the program lies. Okay, so final example, and we wrap up, just to show this kind of flow. I've got some C# here. It's not immediately obvious what's going on, but I seem to be taking a list of words, then I'm sorting it. So I copy a list of words, I'm sorting it, and then I do a whole load of stuff, which seems very mechanical. Let's extract method. I remove duplicates. That's what I'm doing. So wait a minute. I take a bunch of words, I sort them, and then I remove duplicates. Strictly speaking, this is C#, so I can use extension methods. I'm going to make it look like that. But if I'm using the correct terminology, I'm removing adjacent duplicates. What I am creating is a list of words that are unique and sorted. That's not bad. I've reduced it down to 3 lines. I've still got all of that control flow, but at least I've given it intention, and I'm not mixing my levels of abstraction. That's a win. Some people will say, haha, but this is C#. I can use link. And they will come up with something like this. Please don't come up with stuff like this. It's just pointless. The raw version is much better. But are we done? No. Because sometimes it's not a flow problem at all. Sometimes it's a data structuring problem. Why do something when you can be something? Why not be the structure that is sorted and unique? The purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. And this is the important idea. The important idea is to find that expressiveness, to find that structure, and to recognize that when we come to do these things, this is the normal flow of things. This is not Florence Nightingale. This is Isabella Beeton, who is roughly a contemporary of Florence Nightingale, although she died quite young, unfortunately, before she reached the age of 30. She published a series of articles on household management, which were very influential. I love the fact that we can actually find refactoring advice in the 19th century under the guise of how to manage your kitchen. There is no work like early work. Okay, don't leave it till later. Clear as you go. Muddle makes more muddle. You know that code base, you've seen it. Not to wash plates and dishes soon after using makes more work. We push things in, we kind of pitch them into the future in the hope that we might have left by then. And then we arrive at that future and go, oh crap, it's me. This is really important. This is how we develop. There is an idea here that this is the normal part of things. To quote Hemingway, and to close, the only kind of writing is rewriting. Thank you very much.
Thank you, Kevlin. So you're